If everything is a tree in Hyperlambda, and all trees can be executed, and all trees can be represented as file objects or strings, that means everything can be executed. So actually, let's have a look at that in this video. Expand MISC, open your evaluator, and let's create our first reusable Lambda object. Write slots dot, and as you can see here, we have create, delete, exists, and get, and vocabulary, which is just a list of slots. However, we basically have CRUD on slots. Okay, so what is a slot? Well, in order to show that the simplest answer to that probably be to create one. So let's choose slots.create colon foo. Then below, let's do tab return colon int colon 42. This basically returns 42 as an integer value, implying a number instead of a string. Now we haven't dived into types quite yet, but we're going to do that later. Now if we execute this code, we have created a slot. Now first save this snippet, call it tutorial 0401. Why? Because it's a reference in regards to how to create slots. Now we can just delete the code. And then we can do signal colon foo. And what do you think the result is going to be? 42, exactly as an integer value. Why? Because we created a function, quote unquote. And notice I say quote unquote seriously here. Why? Because it's actually not a function, because a function is a static, unchangeable thing. Slot is something that can morph over time into whatever you want it to do. Now, if we want to create a slightly more complex slot, let's invoke slot.create and let's change the foo slot, in fact. And then let's do arguments here. Let's do math.add colon x colon add dot arguments slash all slash, actually let's do 0. And then let's do get value, and let's copy this guy, and let's do 1. Now if we invoke this, we have created a math slot. Let's save this snippet to tutorial, and then let's call, save this one as 0402. Why? Because now we want to delete this guy, and then we want to signal colon foo, and now we can pass in arguments. And we don't even need to, the name of the arguments are irrelevant. Why? Because the expression inside of the slot just retrieves the 0 and the first child. So let's do foo int 5, foo int 7. Hopefully this is going to work. And it didn't, and why? Let's do Control Z, and let's figure out why. Math add arguments, because it didn't return it. Return colon x colon minus. F5 to execute. Let's save it again. Tutorial 0401. I probably saved over my last one, it doesn't matter. Now let's do signal colon foo, blah blah blah, the name doesn't matter, int 5, blah blah blah, name doesn't matter, int 7, invoke, and now we can see we get the sum of 7 plus 5 returned to us. So what have we done now? We have created a reusable slot, or a reusable function if you wish. We have one dilemma though, which is that if the server reboots for some reasons, or if we need this slot to be a reusable Lambda object inside one of our modules, then when we are distributing the module might end up with a 0 null reference exception, which you will see the equivalent of here. Why? Because does not exist in scope. So we need to make sure that this slot is created when the server either restarts for whatever reasons it might need to restart for, or the module is installed in our application pool. The way we would do that typically, we do tools here, and then we open up HyperID, and then we remember the module we had from one of our previous videos called Northwind. Then we can create a special folder here. Notice almost everything in Magic is conventions. And this is not different in any ways whatsoever. So if we create a new folder now called magic.startup, and that's a special folder. Why? Because everything inside of here will be automatically executed as the module is installed and or the server is restarted for whatever reasons it needs to restart for. So inside of this thing, we can now create a new file. Create my slot.hl. Now if we edit this file and we create a slot, and we call it slots.create, and my-slot, return, colon, this is pretty cool. Now, if we don't execute this file, but we save it, and we choose our Northwind folder, and we choose active folder, and we choose download folder, and then we delete the folder. If I now go to the evaluator, and I will invoke signal, colon, my-slot, then it's going to be a null reference exception. My slot does not exist in scope. If I now go back to HyperID, however, and I choose this guy, and I choose general, and I choose install module, and I upload the zip file I just downloaded, then it will automatically execute every single Hyperlambda file recursively inside of my magic.startup folder. So if I now go back to MISC, choose the evaluator, write signal, colon, my-slot, and I execute it, everything is almost kosher. Everything is kosher. So now the slot exists. So this is a by convention type of ability that Magic has in order to make sure that something happens as a module is installed and or the server is restarted. And actually most of the modules you create that contains business logic will typically contain custom slots such as these, which you then should put into a Hyperlambda file inside of your magic.startup folder. And at this point, we so far haven't even looked at this, which is probably kind of weird for a course in regards to a programming language. So let's just make sure we go through this. Every single Hyperlambda file can be commented. This is a comment. You can either comment it like this, or this returns a string to the caller, or like this. And these are called C-style multi-line comments, and these are called C++ style comments. Notice you cannot add a comment at the end of the file like this. If you do, it's going to result in a syntax error. So each comment is actually a separate node by itself, and it needs its own line in order to be able to not choke the Hyperlambda parser some way. Now we can save it, and we now have a comment in the file. If you execute it, it executes perfectly. And by the way, when you're editing slots inside of your Magic Startup folder, if you have any Hyperlambda file, you can just like F5 and it executes the file. Unless the file is an HTTP verb, which the Hyperlambda Magic evaluator can figure out 100% perfectly by itself, at which point it will show the invocation window for your HTTP endpoint. If it's not an endpoint, it will just execute it immediately in immediate mode. So you don't have to use the evaluator to execute code immediately as you're editing slots. You can just execute them, F5, or for that matter, active file, execute. So these are reusable slots, and this is the way you would typically create a reusable slot and associate it with a module of some sort. So these are called dynamic slots. Now, dynamic slots can be, you have CRUD on them, you can create them, you can read them, you can update them, and you can delete them. And in fact, let's read one slot just for kicks. Let's write slots dot, control space, choose get, and then let's do my-slot. So you can see now in the result pane, it actually returns the Lambda object of the slot. If we want to now, we've already seen this with the foo slot a couple of minutes ago, where we was overwriting another slot with new content. Now, this is a feature we cannot do on the native slots. We can only do it on the dynamic slots. Now, with native slots, I basically mean everything you're getting here. And in fact, if you want a list of every single native slot that exists, you can write a vocabulary, and you can choose this guy, and you're getting a list of every single static slot that exists in your particular core. In theory, this might vary from installation to installation, but for all practical concerns, if you register dataista.com for Cloudlet, you're probably going to get the exact same list. Now, if we want to see slots dot vocabulary, we can do that too, right? Now, semantically, slots, dynamic slots and static slots works similarly to each other. However, yet again, there are some differences. A dynamic slot can be overwritten, you can change it, you can edit it, you can retrieve its code, you can modify it on the fly and save it. Again, you can't do that with a static slot. However, if everything can be text and a tree object and all three objects can be executed, then that brings us to a fairly interesting point. Why? Because if we now open up tools, we open up HyperID and we choose, actually we don't need to choose any folder at all. Let's just choose active folder here. Don't click on anything and click new file. Make sure your folder is the root folder here. And then write foo.hl, which point HyperID is going to create a new file for you. Then we can do, for instance, log.info colon, this was logged from your Hyperlambda file. Alt S to save, make sure it says file successfully saved at the bottom here. And then let's go back to MISC evaluator and let's do io.file. And this is going to bring us autocomplete. If you click Control Space now and choose load, type :/foo.hl. As you can see here, we're now loading this file. However, we're currently having the file as text, so let's transform it into lambda by doing hyper to lambda :x minus. Minus, as we saw in the previous video, means the previous node, meaning the content of this node. And the content of this node, as you can see, is the content of the file we are actually loading. If we now execute this, you will now see, if you now execute this, you will now see that it's actually returning the Hyperlambda from the file, and then it's transforming it into a lambda object. Now we can do eval :x minus, at which point if we execute the code, then we open up our log in a different window, we will see this was logged from Hyperlambda file. So we can basically take any piece of text and we can transform it into a lambda object and we can execute that. However, when it comes to files, actually Magic has a native interesting thing, which you can see if you write execute and then click Control Space, and then you find io.file.execute. If we now do :x /foo.hl and we remove this code and we execute it, then if we have a look at our server log, we will see yet another item, just some 3 seconds old, where it says this was logged from your Hyperlambda file. Now the difference between these two constructs is that io.file.execute can actually take arguments. Now, before we actually use that feature, let's open up Tools and HyperID in a different tab. Let's edit this file and let's delete its content, and let's declare an arguments collection. Name, string, age, int. Then let's do strings.concat. By the way, for the record, in case you're interested in what strings function exists, you can click on documentation, you can click on hamburger menu, you can find lambda magic.lambda.strings here somewhere. Here we go. Here you can see every single string manipulation function that exists in Hyperlambda. Anyways, let's do strings.concat get value :x @.arguments /*name (2 double quotes) you are get value :x @.arguments /*age carriage return :2 double quotes space years old. Then we want to do return :x minus, save the file, switch back to our evaluator, and then we want to pass in name Thomas Hansen, age, and let's be honest this time, 48, execute, and well, I can try to write my name correctly, I guess. At the very least, Thomas Hansen, you are 48 years old. So this helper function which basically is called io.file.execute, allows us to treat files as if they were function objects. And we can invoke files the same way we can invoke a dynamically created slot, passing in arguments.